Welcome everyone, welcome back to my channel. Today we are doing surface area and volume of pyramids worksheet. And before that, I want to announce that I have said many times that I run GCSE classes for all subjects, and these micro batches are at just £6 per hour. They are very small batches, highly interactive. If you are doubtful, you can definitely book your free demo and see by yourself. We provide classes for one-on-one as well from year 1 to 13, and that is A levels. So we provide batches and one-on-one both. Plus, if you're looking for free worksheets, just go to edexcel.com, and I have started the crash course for GCSE, and it's really helpful. So I would say that this is the best times to start with. Don't delay it. So even if you are not up to the mark, you are expecting grade 9 or grade 8, but you are lagging, so this is the best time. If you will join our classes, definitely you will improve your grades. Okay, so for that, to book your free demo, you just have to email us at edexcelacademy@gmail.com. Okay, so let me start with the worksheet. Question 1 says, calculate the surface area of the following pyramid. So, total surface area, that means area of all the surfaces that you can see. Here, there are 5 surfaces. The one at the bottom, which is a square base, clearly they have given one dimension. Since they haven't mentioned what kind of pyramid it is, but they have mentioned just one dimension. So, clearly it's going to be a square base pyramid. And then we have to calculate area of these 4 triangles here. So, area of base, since it's a square, so 25 times 25 will give you 625. This is area of square. Now, the area of each triangle is, this base is 25 and height is 50. So, half times base times height, which will give me half times, so area of one triangle is half times base, which is 25, times height, which is 50. That will give you 625 again centimeter squared. Because there are 4 triangles, so it would be area of all triangles is 625 times 4. So ultimately we have to add them up. Area of the square plus area of all the 4 triangles. When I'll add it up, it will be 625 plus 625 times 4, which is 3125 centimeter squared. So that's your total surface area of this pyramid. Moving on to the next question. The surface area of a given pyramid is 1680 centimeters squared. Calculate the area of the base of this pyramid. Clearly, this is a square base pyramid because this and this, the sides AA are given. So clearly I can understand that it's a square base pyramid. So we have to calculate the surface area because the value of surface area is already given. So we have to find the surface area in terms of A so that we can calculate the value of A. That's what they are asking. So area of the surface area, like the surface area of this given pyramid is 1680. And how I can calculate? Same, just like we did the previous question. So area of base plus area of all 4 triangles. So base is A squared, and area of all 4 triangles, area of one triangle is half times base is A times height is 32 times 4. So area of one triangle is half times base A times height, which is 32. And because there are 4 such triangles, so that's why I have multiplied it with 4. And this one is equals to 1680. From here, it will be A squared plus 64A equals 1680. Then A squared plus 64A minus 1680 equals 0. Now it's totally on you how you want to solve this quadratic. Either you can go for quadratic formula method or factorization. Completing the square method would be a difficult one. Generally, the students find it difficult. So you can opt either factorization or quadratic formula, I would always suggest that if you have to find the quadratic and nothing is mentioned what kind of uh, method you're going to apply, just go for formula method. So from here, we'll get two values of A1 as negative 84 and A2 as 20. Obviously, a side cannot be a negative, so we will be selecting 20. So if A is 20, they are asking you to calculate the area of the base of this pyramid. So it's going to be A squared, that is 20 squared. Area would be length squared of a square, and 20 squared is 400. So 400 centimeters squared is the area of this base of the pyramid. Question 3 says, in the above figure, a square base pyramid is given. The diagonal of the base is AC. This is the diagonal of the base. That's given as 8 root 2 centimeters. The vertical height of this pyramid is 6 centimeters. That means this height that's mentioned here is actually 6 centimeters. Calculate the total surface area of this pyramid. See, to calculate the total surface area of this pyramid, we should know this one. Don't get confused. What I have seen that the student does half times base, they take this base and this height. No, this is not the height. We are calculating the area of the triangle. So we need the height of the triangle, which is not given here at all. So, but this one is given, which is the diagonal. If a diagonal is given, the sides are pretty easy to calculate because this is a right triangle. The square has all the sides, all the angles 90 degrees. So that's why this triangle is going to be 90 degrees. So area is going to be triangle. If I apply Pythagoras theorem, so in triangle ACD, on applying Pythagoras, I'll get to know that the hypotenuse, which is AC in this case, the diagonal of the square, is equals to sum of the squares of other two sides. So AC squared is equals to AD squared plus CD squared. Because it's a square, so this and this, they both are same. So let I say this be A and this be A as well. So in place of AC, I'll write 8 root 2 whole squared. And in place of AD, I'll write A squared. In place of CD, I'll write A squared. So this is going to be 64 times 2, which is 128, is equals to 2A squared. And dividing both the sides by 2, I'll get A squared is equals to 64. And on taking root, A will be plus 8 and minus 8, because a side can never be a negative, dimension can never be a negative. So we will take only the positive value, which is 8 centimeters. So now at least we have calculated the length of the base. The height is given, but we need this one. So I can do this one. Suppose this is given here. This is N. We have this base given. This one here, and clearly this base given. This is at the mid. So we have this triangle, then this one. This triangle. This is a right triangle. Because it's perpendicular to the base, though this doesn't seem to be, obviously the diagram is not that accurate, but this is 90 degrees. This is the diagonal and this is the midpoint of it, so it will divide it into two equal halves. So this will be 4 root 2. Height is already given, which is 6, and this is hypotenuse. So let I say this be hypotenuse H. Or there's other way as well. What you can do, you can directly calculate this one. Let me just delete this part. Obviously, this one, this is also the diagonal. This one is also the diagonal. And the square has the same diagonal. So this whole will also be 8 root 2. That means this half part will also be, I'm doing exactly the same thing. The only difference is I'm just trying to clear it through this angle so that you can get a better clarity. Now I think it would be easy to understand that it will make a 90 degree like this. So this is 90 degrees. This height, let I say BO, this height is given as 6 centimeters. This is half of the diagonal, which is 4 root 2. And this side of the triangle is h, the hypotenuse. So h squared is equals to 6 squared plus 4 root 2 whole squared. So 36 plus 16 times 2, which is 32, which is 68. So h squared is 68. From here, h is equals to root of 68. I have calculated root of 68. Now I have to calculate this height, this one, like this. So I have to apply Pythagoras theorem once again. So in this triangle, I have to apply Pythagoras theorem. I'll be explaining you two methods of calculating. So now, since I have calculated this part, that means this basically, let me just show it. This one, I have calculated this one. Then to calculate this is again a right angle triangle. So this is still the hypotenuse of it. So if this hypotenuse is root 68 and a we have calculated as 8, so this is going to be 4. So then this would be, let's say, EO squared plus 4 squared, because these are the two legs of this triangle, is equals to h squared, which is root square of root 68, which is just 68. So EO squared is equals to 68 minus 16, which will give you 52. So EO is finally root of 52. This is a one way of calculating. Why I am explaining, so that you can see it with all the dimensions, through all the dimensions. And if you miss out some parts, at least you'll be able to try the other way. Other way says you have to calculate like this. See, we already have this height. If I draw, because it's at the midpoint, so if I draw this one, it's passing through the midpoint to the side, and then if I'll draw this is a right triangle. Clearly, if I name EO and let's say this be D, say for example, I'm just naming it. D is already there, so let me name it F, sorry. So EFO. This is a single triangle. This is 90 degrees. So applying Pythagoras theorem, here it would be EO squared is equals to FO squared plus EF squared. So FO is what? It's half of the length of this square, which is, length is given as 8. So half would be 4. So 4 squared plus EF squared, which is given as 6. So EO squared is equals to 16 plus 36, which is 52, and EO is root 52. Obviously, this method is much more easier to understand, but since I told you that you have to see everything with different perspectives, you should know that how you can apply, what all things you can apply here, and that's why I have explained you. Now, since we have this value, let me find the others. Now to calculate the total surface area, we have to calculate the area of the base, because base is 8. That means the length is 8. So base is going to be 8 squared. So I'm just writing here. So area of base, that is for the square, is 8 squared, which is 64. And for triangle, this triangle is half times base times height. So half times base is 8 and height we just calculated as root 52. This one. This is 8 and this is root 52, and multiplied with 4. So this will be 16 root 52. This can be written as 16 times 2 root 13, which is 32 times root 13. That's the area of the triangle. Now add it up. So finally the surface area is 64 plus 32 root 13 centimeters squared. Because the initial it was given in under root, that means in a surd form. That's why I have given the answer in surd form. Though it's mentioned nothing there how they want the answer to be. If they want the answer to be in surds, write like this. And if it's written that answer should be up to 1 decimal place, 2 decimal place, so you just have to calculate it and get the answer. Moving on to the next one, the question 4 says a rectangle based pyramid. Now here it's clearly mentioned that it's a rectangle based, and here I can also see that one is 7 centimeters and another is 8. So it's basically a rectangle. And we have to calculate the volume. So the formula to calculate volume of a pyramid is 1 over 3 times area of base times height. We know that area of this base, which is a rectangle, is length times width. So 1 over 3 and area of this base is 7 times 8 times height, which is given as 10 centimeters here. So times 10. This is going to be 560 over 3. That's your final answer. Either you can convert it into decimal or leave it in fraction. That's totally on you. Centimeter squared, that's the cube, that's the volume. Moving on to the next. Question 5 says the volume of a regular tetrahedron. Tetrahedron is also a pyramid. The base is triangle, and in any pyramid the sides are always triangles, but here it's a triangular based. So triangular based pyramid is called tetrahedron, and it's a regular tetrahedron, which means all the sides are exactly the same. That means all the 4 triangles, because the base is one triangle here, and because of this base, this side will lead to one triangle, this side will lead to another triangle, and this side will lead to another triangle, that is the front one. So in total there are 4 triangles, and all 4 triangles are actually equilateral triangle. That means how many dimensions that you can see here, that means all the dimensions simply, not the height, I'm just talking about the sides of the triangle, they all are same. If it's mentioned here it's A, that means every side of this triangle is A. So the volume of tetrahedron is given as, the regular one is given as 12 root 3 centimeter cubed. Calculate the value of A. There is a direct formula to calculate the area of the equilateral triangle. If you don't know, we can go by the method that I'll explain. This is the formula, which is root 3 over 4A squared, and A represents the side of this tetrahedron. If you don't know, if you're not able to remember it, you can apply sine rule. So the other method says an equilateral triangle has all the angles same. So if you apply angle sum property, you get to know that all the angles are 60 degrees and all the sides are A. So let me just draw an equilateral triangle. All the sides are A and all the angles are 60 degrees. Now if you apply the formula to calculate area of the triangle, it's not right triangle, half times base times height, which is actually a modified ones of the area of a triangle, which is half times multiply 2 sides that are just adjacent. So A times A squared times sine of angle in between them. So these 2 adjacent sides we have taken and an angle between them. You can take any 2 adjacent sides and angle between them, which is sine 60 degrees. So it's going to be half times A squared times sine 60, which is root 3 over 2. Finally, you'll get root 3 over 4A squared, which I already told you. This is how you can calculate area of a triangle. So the base has A side. So I can say the area of this base as well as area of all the four triangles are root 3 over 4a squared. So now we have already calculated the area of the base, which is root 3 by 4a squared. So we just have to apply the formula for volume of the tetrahedron, which is 1 over 3 times area of base times height. So this is going to be 1 over 3. Area of the base is root 3 by 4a squared times height, which is 4, and this is equals to 12 root 3. From here, I can cancel out these two. Final answer is root 3 over 3a squared, and this is equals to 12 root 3. Now I can cancel out root 3 and root 3 from both the sides. It will be now a squared by 3 equals 12, and a squared is equals to 36, and finally taking the root, it will be plus minus 6. But as I told you, we cannot take the negative as dimension, negative value. So answer is 6. So the value of A is 6 centimeters. Moving on to the next question. Question 6 is, in the given figure, a pyramid is inscribed inside a cube of side 10 centimeters. Calculate the volume of the space inside the cube which is not covered by the pyramid. Which means clearly we just have to calculate the volume of this whole cube, then volume of this pyramid, and subtract. It will give you the volume of the space that is not covered by the pyramid. It's very clear. So let me start by finding the volume of cube. So I can write volume of space that they are asking you to calculate is equals to volume of cube minus volume of pyramid. So volume of cube is length cubed, because we have all the sides same. So length times width times height, which is 10 times 10 times 10 would give you 1000. So 10 times 10 times 10 minus volume of pyramid, we have seen it's 1 over 3 area of base times height. So clearly this area of base, which is a square of dimension 10 times 10, is the same the area of this pyramid, the base of the pyramid. So base of the cube and the base of pyramid is exactly the same, which is a square of dimension 10 centimeters. So I can say that the area of base is 10 times 10 times height, and height is exactly the same, which is height of the cube, that is 10. So which is 10 as well. So from here I can say 1000 minus 1000 over 3, which is 2 over 3 times 1000, or 2000 over 3. So either we can leave this answer as 2000 over 3, or in decimals I can write 666.67 centimeter cubed. That's the space which is not covered by the pyramid. Moving on to the next one. The volume of the given hexagonal pyramid, that means the hexagonal base pyramid, is 144 centimeter cubed. The height of the pyramid is 6 root 3 centimeters. So we have to find the length of each side of this hexagon, that is at the base. Volume is given, so I'll apply the formula, which is 1 over 3 area of the base times height. This is equals to volume. So 1 over 3 area of the base, let it be just like this because we don't know. Height is given, which is 6 root 3, equals to volume, which is 144. From here, area of base, which let me denote it with B, times 6 root 3 is equals to, multiply both the sides by 3, it would be this. Finally, B, that is the area of the base, is 144 times 3 over 6 root 3. This is the area of the base. I'm not solving it further, let it be like this. Or if you want, we can do it's very easy like this. 2 you'll get, and here you'll get 72. 72 over root 3. If you think like I have to simplify it further, so let it be like this now. Then we have to work on the finding the area of the regular hexagon, because we have the value of area of hexagon now. But how can I find in terms of the side? Let's say each side is 8 because this is a regular hexagon. So I have to draw this one. This is a regular hexagon. Let me just draw it once again. This one. Oh, sorry. Okay, this one. Okay, now each side is A. I can divide a regular hexagon into 6 equilateral triangles. So which means now these sides are also A. This A. And we just have seen that area of equilateral triangle is 3 root 3 over 4a squared. And there are 6 such triangles, so multiplied by 6. So root 3a squared times 3 over 2, or 3 root 3a squared by 2 is the area of the hexagon. Also, we have calculated the area of hexagon as 72 over root 3. So it's a time to equate them, and it will give me 72 over root 3. Multiply or cross multiply. It will go up there, it will go up there. So I'll get 3 root 3a squared times root 3 equals 72 times 2. This will give me 9a squared is equals to 144. A squared is equals to 144 over 9. Taking root, so a will be 12 over 3, which is 4. So that's your final answer. So length of each side of this hexagon is 4 centimeters. Moving on to the question number 8. In the figure given above, a pyramid is placed on the top of the cube. Height of the pyramid is 1/3 the height of the cube. Now, if the total volume of this shape is 240 centimeter cubed, then we have to calculate the length of the cube, calculate the total surface area of the cube. So, if the height of this pyramid, okay, it says 1/3 as of the height of the cube. So let's say the height of the cube be x. So this is going to be 1/3 of it, which is 1/3x. And it says the total volume of this shape, that means volume of cube plus volume of pyramid. So volume of cube plus volume of pyramid is equals to 240. So volume of cube, we know length times width times height, and cube has all the sides equal, so it's going to be x cubed, plus volume of pyramid is 1/3 times area of the base times height. So 1/3 area of base is a square, which is length times width, that is x squared, times height, which is 1/3x, equals 240. From here, I can write x cubed plus x cubed over 9, which is 240. 10x cubed over 9 is equals to 240. And from here, x cubed is equals to 240 times 9 over 10, that is 24 times 9. This is equals to x cubed. So x cubed is equals to 216. On cube rooting, I get x as 6 centimeters. So we have the dimensions now. So calculate the length of the cube, which is x, that is 6 centimeters we have calculated. Then calculate the total surface area of a cube. The total surface area of a cube is 6a squared, that's the formula. So 6a squared, that is 6 times 6 squared, which is 216. So this is 216 centimeters squared. Calculate the total surface area of this shape. For this shape, how many surfaces can you see? The bottom one, which is a square, 1, and the four sides of this cube. Okay, leave the upper, like the part that is above there, this one, the upper part, because upper part is now covered with this whole pyramid, so we can't see it, and the surface that we can't see, obviously that's not be counted into total surface area. So we have five surfaces, five squares here. So for total surface area, I would be writing total surface area of this whole figure is 5 squares. Clearly, what five? All five squares. The bottom square, this one, this the bottom square, and these four, like that, the sides. And each one is a square of side 6 centimeters. So 6 squared times 5. Each square, which is the area is 6 squared, and there are 5 such surfaces, so 6 squared times 5. Now we have 4 triangles. We know the height of these each is 1 over 3x. This one, this height is 1 over 3x, that is 2. This height is 2. This is 6. So we know this is going to be this one. If I do like this one, or directly, because I want to calculate the height of this, to calculate the surface area I should know the height of the triangle, which is this one. Clearly this is height of the triangle, but that we don't have. For that we know the vertical height here, which is 2. This length, which is again half, because this is the midpoint, so this is 6, so this is half, that is 3 centimeters. This is the same thing that we did in our previous question. And now this is hypotenuse that we have to calculate. Let's say this be h. So h squared is equals to 2 squared plus 3 squared, 4 plus 9, that is 13. So h is root 13. So we know the base is 6 and height is root 13. So area of one triangle now, area of one triangle is half times base is 6 times height, which is root 13. So 3 root 13 would be the answer for area of one triangle. Then area of 4 triangles would be 4 times 3 root 13, which is 12 root 13. So total surface area would be now 36 times 5 plus 12 root 13. So this is going to be area of the all 5 surfaces is 180, and area of all 5 triangles is 10.81. That will give you 190.81 centimeters squared. That's the total surface area. So this was our last question. So that's it for today. Once again, if you're looking for GCSE crash courses, this is the best and the right time to book your free demo. And also if you're looking for A-level classes or classes for any year from year 1 to year 13, that is still A-levels, you just have to drop us an email at edexcelacademy@gmail.com. And if you're looking for these free worksheets, you just have to go to our website, which is edexcelacademy.com.